Hello. 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 Can you hear me? Hello.
Hello?
Yeah, I can hear you.
Yes, yes, I'm hearing you.
Okay, so nice to meet again. Okay. So basically now I talked about that how we can easily make that wind speed using the formula of that. Okay, so mainly root is square root u square plus v square. Okay, so this is the formula about that. Formula is that mainly speed formula physics. I simply search and this formula have that.
Can you please share your screen?
That's it.
Hello? Hello?
Okay, can you hear me?
Yes, I can hear you. Can you please share your screen?
Yeah, yes. Okay, so in this time, first of all, we have to know about the formula. In this formula, we talk about that original velocity and we talk about the terminal velocity. Okay, so you send me the basically u and v. So I also write the formula in here. One formula is that u square, mainly u square plus e square. Okay, so it's that original velocity and it's the terminal velocity and overall square root. Okay, so square root. So when I apply the square root, u square plus v square, mainly original velocity and terminal velocity summation and square root, then we can get that main velocity. Yes, so this is the formula. Is it okay? This formula. Hello, can you hear me?
I'm hearing you.
Yeah, so this formula is the okay, yeah?
Okay.
Okay. So now in this time we have to use this data set. Mainly you can see this is the ERA5 monthly aggregated climate reanalysis data set. Here we find out that two things. One is the U, mainly which is identify about the original temperature, and we can also get the another thing is that V, which is mainly show the terminal temperature, mainly speed. Sorry. So in this time, this is the one band, and this is the another band. Okay. So in this time, you can see meter per square second, meter per square second. So in this time, we are just calculating these two things from here, and then make the uh, total velocity. Okay. So let's go. Just I try to add. Suppose I take the any study area. I take this type of coastal land study area, and further I take a variable. Suppose I put the variable name is that um I put the value. Suppose it's that terminal or original. So original. Suppose original velocity for v, and I just simply call this image collection. So basically in this time where you said this is the image collection. Here you can see I can simply copy this snippet from here and I just paste here. Okay, so this is my mesh collection. From here, I just select only for the specific band, mainly it's called that original mainly it's the original velocity. So basically I put here the suppose u, it also better, we can suppose u for it's that no, symbol for that original velocity, and v for terminal velocity. Okay, so I put that original u, and I simply call this u component. Basically you can see this is the u component of moving 10 meter. I simply copy these things and then paste here. So now we can get the result for original velocity band. I simply call in here, and further you have to choose the time period. Any time period, simply choose suppose filter date, and put here this time period, suppose year of 2020, or I put the suppose 23 1st January from, suppose any time period you can put, suppose 2008 1st January from, I put this time, and in time suppose year of 2023 December 31. So I take the one year, this data, original velocity, and further I just calculated that mean or average result, and it also click with my study area which is ROI. Okay, so now this is the variable stored this only for original velocity, and I also take the another variable and take that another velocity, mainly it's called that terminal velocity. So I change it, suppose it is a terminal, it's v, and I call this band name which is v component of wind 10 meter, and further I just simply change this band name. Okay, and also calculate the mean. Okay, so now I just further calculate the total velocity using this formula. So for doing this formula, we just take a variable. Suppose I put the variable name is that velocity, velocity, and then I simply call these things. It's the power. In this time we put here that pure w function, and put here dot number, and also put here the 2. So this power will be add with that terminal velocity. So add with terminal will see this is terminal. I simply call it and paste here, and it also have the power 2. So I put here the POW power, and put here dot number. I put the number 2. So power 2. So now whole things I have to under that square root function. So I simply search there what is the function for square root. Suppose SQR. Okay, so this function is the SQRT. So just I put here that this function which is SQRT. Okay, SQRT we try to add in here. Compute the square root of the input. So now we try to have dot add layer function. And this time, okay, so it's showing that square root is not defined. Okay, so for that, you can also do for another things. Suppose, eh, okay, so we can do the another thing. Work. So for that, suppose I call these things, and then I just put here the expression expression. In this expression, I simply put my formula. So I put the formula is that u power 2 plus b power 2. Then these things we are just calculate the square root. Square root mainly it's called the power 0.5. Okay, so 0.5 means that square root. Okay, so
Okay.
just further here just here these things. Suppose I call this original u. Okay, I call this in here u. What is the u? U mainly it come from this imagery, and then select the band u component. I just paste here, and v mainly it also come from that same imagery, and paste here, and select select the band of v component wind. I simply copy and paste here, and further in this time it's not need, I remove that, it's not need, we just take only for the one, and it in this time I'll just take the another band which is, yeah, this band is able to select in here. So now in this time it's our image collection, or okay, so this image collection, okay, I think it's not need because we select this band later. We just simply put the time period only for the time period, and then this from this image collection we are just generating this is our image collection this time period, and from here I calculate the velocity, so that's why I need this two band, and further I am trying to add in here, then try checking so that expression is not a function. Okay, okay, so for that we can do, for that we try to calculate that suppose mean, and it also clip with our study area of RY. Okay, so now it's work, yeah, perfectly, yeah. And now I also want to focus the center of the shape file. So just say simple right here, map dot center object is RY. So now let's check about the result of velocity, what we can get from here. Okay, so we can get this type of velocity. So it's the total velocity, mainly terminal velocity, and also we can find out that start velocity or original velocity. So now here you can see you can get this type of map, and we don't understand what the high and low. So for that, simply click on here, and then click to the stress in 98%. Then try to add the plated. So for that, I simply, so here is the low velocity. It shows suppose this type of green color. Greater then show about that yellow color, and high velocity show about this type of red color. Then apply that. So now we can get this type of map here. You can see. So basically, this type of coastal, let me find out that high velocity about this. So it's the total velocity. Just we can get this type of things. Or if you want, you can also try to add the suppose whole country boundary of Bangladesh. Then check what happened. Suppose I simply import that whole country boundary of Bangladesh and remove the previous RY, and then add here that RY. Okay, so we can get the whole country boundary wind speed, total wind speed mass. So further we can check what happened. So just click on here, and then okay, stress 98%, 98%. Then plated, suppose here I find out that low, it showed this type of green color. Greater than, it shows about this type of green color. I also the more color. and then suppose show this type of yellow color, and high show this type of red color, and further apply. So now we can easily get the idea where is the high and low temperature. Or if you want, you can simply suppose you just put the three color. One is that high, further I simply put at that yellow, and further show about that red color. Right? Yes. Okay, so now I can get the wind speed. So now we talk about that time series chart because we need the wind speed time series. We not only for the map, we also talk about the time series. So that's why we can easily make the correlation with that chlorophyll. Okay, so let's we talk about the time series, mainly velocity time series. For doing these things, first of all, we have to need a function. We have to create a function. This function we have to connect with our image collection. So let's go try to make a function. So for function, just take a variable. I just put the suppose add velocity and function keyword, put the image, curly bracket. Simply put my argument. My argument is that calculate the velocity, and I want to calculate using this image. Then further, I just simply put the expression, and then my expression is that my expression. So I try to copy it from here. So just I put here the expression from copy and paste here. It's the same. I just simply put the expression and then other things. And in this time I put here the img image and also put here that img. So this is my function. This I created. This function I to connect with my image collection. So basically in this time my image collection is that this is my collection. So I put the collection in better. Simply copy and also put at this collection. So now further I just simply copy this collection, and this collection I do add with my function. So for that click on here, and in this time don't need to use the mean function because I need to make the collection. So just put here the map function and call the add velocity, and then paste here. So now try to make the time series chart. So for doing these things, we are just and also we can put here the rename function suppose, and finally we return from here. Suppose I want to return this image add bands with mainly I put the velocity. So it's a velocity, and I also put here the rename. I put the rename as a new band. I put the name suppose it's a V or velocity. Okay? So then further we make the time series chart. This time series chart I simply take a variable. Suppose I put the chart and UI dot chart dot image dot series, and further click on here. So just make a curly bracket start and also curly bracket in here. So first of all, image collection. I already make the image collection. So I simply call that QL collection, and then select the band of velocity. I simply call the select the band of velocity. Simply copy and paste it. Then study area. So mainly it's a RY. So put here that RY. Reducer I need to calculate it that average velocity. So put here EE dot reducer dot mean. And further I try to calculate the scale. Scale mainly it's the resolution of your satellite images. We can see about the resolution. So it's called the resolution is the 1113 32. So just I simply copy same scale value, and then put the property. So basically it's a put here system time start. Now further print the chart, then we can easily get the chart of that. So now it make the chart between this time period of 2023. Okay. It will see well. So now take a check. So now you can see it show the time series chart look like that.
Okay.
Okay.
Mm-hmm.
And now in this time you can see January, February, March, April, May, then June, July, August, September, October, November, and December. So it's provide you monthly velocity. So now what you can do, you can simply download this CSV file where you can find out that monthly CSV, monthly uh, velocity of wind, and then you can just simply use the same code. Okay, then you can just try to find out the correlation between these two things. So I will send you this code link also. You try to find out that download the time series chart for your study area and try to use the previous. So suppose Google Colab code link I already send you. Add the data with the chlorophyll and the velocity or wind speed, and then try to find out the correlation. Okay.
Mm. This is good. I wish you could have the time we just set the data set. I mean the code for the velocity, the temperature, and the precipitation. Then I can use the analysis myself because to build the code, that's where my problem is. Sometimes, like if I encounter problem, I had to come back. Yes, I you saw how to build this code just now. We had to be going back and forth, and finally we got it. You were able to get it because you have some prior knowledge and stuff. But for me, no. And I don't have no time now, so I'm just building. If we can build a code for the temperature and the precipitation, then I can use that now to
Okay. Okay. Let's.
just
I understand. Yeah. Yeah. So in this time, wind speed is the okay. I hope you can easily
yeah.
get the time series chart wind speed. So in this time, I also try to add the code for time series chart of temperature. Okay. So for the temperature, we have to use the dataset. Mainly, you want to use at that which dataset you want to use for the temperature?
The ER5, the CER5.
Mhm. Okay, we have to use the same data. It also okay for you, no problem. And in this time, if I okay, it's very easy. We can easily do it. You can see here for the temperature. Mainly, this is the temperature 2 meter, and I think yeah, this is the band about that temperature of air 2 meter above surface of land, sea or inland waters. So you can also use it, no problem. Yeah,
Mhm.
for the temperature, you can also use it for the temperature. I think okay, so temperature level one, and you can see different types of temperature is available. So I want to use at this temperature, the temperature 2 meter. Simply copy and further in this time, I just try to add a new band for temperature. Okay. So now at the same time, we can get the another line for temperature. And now it also show the temperature for monthly temperature. We can also get. Okay, here you can see we can get the temperature.
Mm.
And this is the, for that your velocity. Suppose I need for the precipitation. Just I simply find out the band of precipitation. That is it. Precipitation. The total precipitation sum. Yeah. So this is the we can also use it. It is the total precipitation sum. Okay, we try to use it. So just I simply copy, and further I try to add these things in here. Okay. So then click to the run. So in this time it create the another line which identify about the total precipitation. So at a one chart we can do, okay, all of our velocity, temperature, precipitation. Suppose you need only for the precipitation in one chart, you can simply remove these two, velocity and temperature. Then we can get only for the total precipitation. You need only for the suppose temperature, then remove the velocity and total precipitation. Then we can get that only for the temperature. Okay. And when you need only for the velocity, just you can simply remove the two things, then you can get the result only for the velocity. And now this chart show at the same time for three property. So just I simply click on here and show you the result. Suppose I download the CSV and then try to open this CSV file. Now it show me all of those data in one Excel file. So here you can see, yeah. So we can say I can get this one Excel file for that monthly velocity. I can get the monthly temperature. I can get the monthly precipitation result. Okay, and
Okay.
it show about that Kelvin unit, and it show the meter per second, and I think it show about the millimeter. Okay, so this is the process you can see. You can get the velocity, temperature, and total precipitation for 1 year, mainly monthly. And you generate from for the previous you try to generate from that LG, and further you can simply make the two column for velocity and temperature, and then you can easily make the correlation between the temperature, velocity, and also precipitation with the LG. Okay.
In one graph, is it possible that to do the correlation for the three data set or maybe just two?
Okay, basically correlation it's depend on for two, only for the two variable.
Yes, only for the
Suppose,
two.
yeah,
So they have okay.
suppose precipitation with LG, precipitation with precipitation with LG, then temperature with LG, then also for velocity
Waste.
with the LG. Yeah, so we can get only for the two variable and create the individual chart for correlation.
Okay. Mhm.
Okay, so I hope you can get this idea. Yes.
Okay.
Okay, so I'll send the code link. You try. I hope you can easily do it. So now you can get all of those data, and you already have the your collab code for the correlation. So you just try to set these things. I hope you can easily get it for that. And further face any problem, then also knock me. Or tomorrow you can also meet for that solution. Okay.
Okay. Thank you.
Okay. Thank you. Have a good day. Okay. Bye.